Implement VRF-Lite, virtual routing and forwarding. This topology. Okay, I will use router Cisco 7200. Okay, here this is my Cisco 7200 with iOS 15.0. Three routers. Okay, and use three switches, A1, D1, and D2. I will use Cisco iOS VL2. This will be A1, A1, D1, and D2. And two PCs, PC1 and PC3. I will use a VirtualBox virtual machine for PC1 and for PC3. And connect them between R2 and R1 gigabit 00. I will use gigabit 00 on both sides. And serial interface between R1 and R3. I will use a 30, 30 gigabit interface, gigabit 001 to fast Ethernet 11 on A1. I will use gigabit 10 to gigabit 11. Fast Ethernet 1 to gigabit 105. Okay, I will use gigabit 1 to 5, and I will use 11. And from fast Ethernet 3 to gigabit 5, 3 to I will use 11. And for PC 23 on both cases, I will use 2.3. addressing table, just like the topology. By default, all interfaces on a router are included in the global routing table. Service providers must be able to virtualize the router, thus creating multiple virtual routing tables. Virtual routing and forwarding (VRF) can do just that. VRF-Lite is the VRF without the MPLS component. You will work on R1 playing the part of the service provider router as it supports two customers who have the same addressing scheme configured. Your task is to deploy VRF-Lite and static routing so that the customers have full reachability within their network. This lab is an exercise in developing and deploying and verifying VRF-Lite and does not reflect networking best practices. The PCs used in this lab do not require addressing. They are needed to bring interface VLAN 11 up. Required resources on real lab 3 routers Cisco 4221. In my case, I'm using Cisco IOS VL2. Okay, Cisco IOS VL2 for 2 switches, Cisco 3650. In my case, I'm using Cisco IOS VL2. 1 switch 2960. In my case, I'm using image Cisco IOS VL2. 2 PCs, I'm using 2 PCs on VirtualBox. Build the network, configure basic device settings. Okay, cable the network, ready, configure basic settings. Okay, copy all this to Notepad. Copy. Paste. Okay, router R1. Okay, enable configure terminal hostname, unicast routing, banner, line console, BTY. Okay, now go to R2. Enable hostname. Okay, but on R2, configure gigabit 000. In my case, on R2, I'm using gigabit 00. So modify this gigabit 00. Okay, loopback 0, very nice. IP root, IPv4, IPv6. Router R3. Enable hostname, banner, lines, serial 010. In my case, on R3, serial 30. Okay, use 30. Loopback interface, IP, static root, IPv6, switch D1, enable hostname, line. Okay, shut down all interfaces. Okay, all the range of interfaces. But in my case, the range is different. On D1, from 00 to 03, from 10 to 13, from 20 to 23, and from 30 to 33. Okay, gigabit from 00 to 03, from 10 to 13, from 20 to 23, from 30 to 33. Okay, shut down all interfaces and gigabit 5. In my case, it's gigabit 11. Gigabit 11. Okay, and no switch port, routed port. Okay, VLAN 11 and 23 for the PC. In my case, I'm using 23. 23 for the PC. IP root, and look at this. You will use 5. In my case, 5 is 11. Okay, is this 11? 11. And also for IPv6 root, 11. Okay, and in the previous configuration on R3, serial 010, in my case is serial 30. Okay, serial 30. Okay, serial 30 for IPv4 root, for IPv6 root, and also for R2, the local interface is gigabit 00. Okay, on R2, gigabit 00. Okay, here for static roots, IPv4 static root and IPv6 static root. Okay, R1, no IP configurations. R2, gigabit 00, loopback 0, static root 00, 00 in my case. R3, serial 30, loopback, serial 30, serial 30. D1, shut down all interfaces, configure gigabit 11, that is this. VLAN 11, gigabit 23 for the PC connection, gigabit 11 for static root, switch D2, enable configure terminal. Okay, shut down all interfaces, use the same range as the previous switch. Okay, on D2, shut down all interfaces. And from, instead of 5 is gigabit 11, interface VLAN 11, instead of 23 is 23, and for a static root is gigabit 11, gigabit 11, switch A1. Okay, shut down all interfaces, so use the same command to select all the range on the image Cisco iOS VL2. Shut down all interfaces on switch A1. Okay, switch A1. And VLAN 5, 8. Okay, no IP configuration. This will act as layer 2 switch. And now start R1. start R2, start R3, start A1, start D1, and start D2. Okay, go to R1, double click, paste the basic configuration. Okay, enable command, so you don't need to apply. You are on privilege exec mode, so only copy from configure terminal and right click to paste. Okay, very good. R2, copy, and only from configure terminal, copy. Right click to paste. Okay, very nice. No errors, no issues. R3, configure terminal, copy. Right click to paste. Very, very nice. Switch D1. Okay, wait a moment. Okay, for D1, copy enable, configure terminal. Okay, copy, enter, and right click to paste. Look at this. No issues, no errors. Okay, and switch D2. Copy, right click to paste. Okay, very nice. And switch A1. The VLAN configuration. Right click to paste. Okay, and remember that if you will configure the trunk, also configure the encapsulation. Okay, before the trunk, configure the encapsulation. Switch port, trunk, native sorry, switchboard trunk encapsulation.1q. Okay, and do this all again. Okay, because capacitor 11 switchboard mode trunk was not accepted. You should configure the encapsulation. And remember, it's not 11, it's gigabit 11 and gigabit 01 and 03. Here is gigabit 11, gigabit 01, and gigabit 03. Okay, gigabit 11, gigabit 01, and gigabit 03. Okay, and copy again. Copy. Right click to paste. Okay, very good. Okay, no issues, no errors. Configure and verify VRF virtual routing and forwarding interface addressing. You will configure and verify VRF-Lite on R1. The other devices R2, R3, D1, D2, and I1 require no additional configuration. Once again, the configuration being used here is not meant to represent best practice, but to assess your ability to complete the required configurations. On R1, create the required BRFs, create the customer A and customer B BRFs, and initialize them for both IPv4 and IPv6. The BRF names are case sensitive. Okay, create the BRFs on R1. Global configuration modes. BRF definition customer underscore A include address family dash family IPv4 and IPv6. Exit and define BRF definition customer underscore B include IPv4 and IPv6. Exit. Exit again. Okay, so you are on global configuration mode again and configure gigabit 00 and serial 30 for customer A. Okay, look at this, gigabit 00 and serial 30 for customer A. Okay, gigabit 00 and serial 30. Interface gigabit 00, BRF forwarding customer underscore A, case sensitive, and set the IP address 10.121.24, IPv6 address, link local address A0 ::1:1, link local, and IPv6 address 2001 DB8 ACAD 1012::1 prefix 64. Okay, 1012. Enter no shutdown to enable this interface. And now configure serial interface. Remember, it's serial 30 also on customer A. Okay, interface serial 30. Okay, assign to customer A the addressing 10.131, link local FE8014 global unicast address 1013::1 no shutdown exit. Okay, very good. And now configure R1 interface gigabit 10 to support customer B. And gigabit 10 will be performing inter-VLAN routing between VLANs 5 and 8. Okay, in my case it's gigabit 10 on R1, gigabit 10 for customer B, and configure on sub interfaces and inter-VLAN routing. Okay, for VLAN 5 and VLAN 8. Okay, sub interfaces 5 and 8. Okay, interface gigabit 10 in my case, and enable the interface at the end. For now, sub interface 5, set the encapsulation .1q5, assign this to customer B, VRF forwarding customer underscore B, the IP address 10.1.21.24. Okay, the same IP address on gigabit 00. The difference is that gigabit 105 is on customer B, but the IPv4 address is the same. And also, link local address will be different. Okay, will be different. So this link local address is 2.1.2. Okay, FE80::12 link local. But the IPv6 address is the same. Okay, the same like gigabit 00. The same IPv6 address. Enter. Now go to sub interface 8. Okay, now configure this, and we'll have the same IPv6 address like serial interface. IPv4 and IPv6 address is the same like serial interface. 108. Encapsulation 8. Customer B. Okay, remember it's on customer B. Okay, the same IPv4 address like serial interface. The link local address is 3 in this case. Okay, 3.1.3.1.3. And the IPv6 address is the same like serial interface. And go to the physical interface, gigabit 10, and enable, not shut down. Okay. And verify. Instead of use show IP interfaces, use show IP BRF interfaces. And show IP BRF interfaces. Now you can see gigabit 00 and serial on customer A, and sub interfaces 5 and 8 to customer B. Gigabit 00 has the same IP address like sub interface 5, and serial interface has the same IP address like sub interface 8. Okay, gigabit 00 and 03 on customer A, and sub interfaces on customer B. Okay, and show IP route BRF customer A and pipe begin gateway. Okay, verify the routing tables. Okay, show IP route BRF customer A case sensitive customer underscore A begin gateway. Enter. Now you can see the directly connected networks on customer A, only two. Okay, 10120 and 10130. Okay, 10120 and 10130. Okay, and for verify for customer B on IPv4, customer B, but 10120 and 10130, but on sub interfaces 5, sub interface 8, but for customer B. Okay, for customer B, 10120 and 10130 on sub interfaces. The difference is here you are using sub interfaces, and here you are using gigabit interface and serial interface. Serial gigabit for customer A, customer B sub interfaces. So there are two virtual routing tables, customer A and customer B. But now verify the IPv6 routing table. Only repeat show IPv6 route BRF customer A. Okay, enter. Two directly connected networks, 1012, 1013, but on gigabit 0 and on serial interface. 1012, 1013 on gigabit and serial. And now verify show IPv6 route BRF for customer B, and you have 1012 on sub interface 5, 1013 on sub interface 8. Okay. 1012 on sub interface 5 and 1013 sub interface 8. Okay, so you have two different virtual routing tables on IPv6. Okay, verify NetHub reachability within each VRF, and use ping VRF. Okay, ping VRF customer A. Okay, on R1, ping VRF customer underscore A case sensitive, and the destination IP address. The NetHub 10122. Okay, on customer A, NetHub 10122. 10122. 10122. Success. And also ping on IPv6 10122. 10122. Ping customer A ping VRF customer 2001 DB8 ACAD 1012 colon 2. Success. And the another side on customer A, okay, customer A 10132. Okay, this another side success, and the another side on IPv6 10132. Enter. Success. And obviously you can ping the another side, for example this IP 10122 but on customer B on R1, 10122 but on customer B. Success. And the IPv6 10122 but on customer B. Success. Okay, very nice. And ping the another side but on customer B 10132 but on customer B. Success. 1013 colon 2 on customer B. Success. Configure and verify static routing for reachability inside each VRF. You will configure static routing so that all networks are reachable within their respective VRFs. At the end of this part, R1 should be able to successfully source a ping from interface loopback 0 to R3 interface loopback 0. And D1 should be able to successfully source a ping from interface VLAN 11 to D2 interface VLAN 11. Once again, the way these networks are being implemented is not meant to represent best practice, but to assess your ability to complete the required configurations. Verify that distant networks are not reachable within each VRF. Okay, you will check to make sure that distant networks are not reachable from R1 within each VRF. Okay, on R1, commands ping VRF customer A 192.168.2.1 and ping VRF customer A 192.168.3.1. Neither should succeed. Okay, try to ping from R1, try to ping loopback 0 to 1 and loopback 0 on R3 192.168.3.1. Okay, try to ping loopback 0 on R2 192.168.2.1 and loopback 0 on R3 192.168.3.1. Okay, ping VRF customer A 192.168.2.1. Okay, should fail. Okay, and try to ping 3.1 on customer A. Should fail. Obviously, you need routing for this. Okay, and the same commands but using IPv6. Okay, try to ping loopback 0 on IPv6 2000 colon 1 and 3000 colon 1. Okay, ping VRF customer A 2000 colon 1. No valid root, no valid source address. Okay, and 30001. Okay, no valid source. Okay, try to ping the another side on customer B on IPv4 and on IPv6. Okay, try to ping interface VLAN 11 on IPv4 and IPv6 and interface VLAN 11 on D2 with IPv4 and IPv6. Okay, try on customer B, try to ping these distant networks. Okay, customer B, ping VRF customer B 192.168.2.1. Okay, this will fail. Okay, to this on customer B 231. On IPv6, customer B 2000:1 fail, and customer B 3000:1. Very nice. And now configure static routing at R1 for each VRF. You will configure R1 so that it can reach distant networks in each VRF. The network system D1, D2, R2, and R3 have static routes already configured. So as soon as you can correctly install these static routes, there will be full reachability within each VRF. Okay, obviously configure on R1 VRF static routes, virtual static routes for each customer, but first start with customer A on IPv4 and IPv6. Okay, configure terminal IP route VRF customer underscore A and reach the remote network. Okay, the remote network is 192.168.2.0, 192.168.2.0, subnet mask 24. The local interface is gigabit 00 and NetHub IP address 10.1.2.2. Gigabit 00, 10.1.2.2. Okay, for the another side is 30 and NetHub 10.1.3.2. Okay, customer A 30 gigabit. The local interface is serial 30, and the NetHub 10.1.3.2. In the same way, for IPv6 route VRF customer A, the destination 2001 DB8 ACAD 2000 prefix 64. Okay, the destination is this 2000 and local interface gigabit 00 and NetHub IP address is 10.1.2.2. Okay, gigabit 00 and NetHub 2001 DB8 ACAD and 10.12:2. Okay, review IPv6 route VRF customer A 2001 DB8 ACAD 2000. Local interface gigabit 00 NetHub 2001 DB8 ACAD 10.1.2.2. Enter. Very nice. And for the another side, IPv6 route VRF customer A Okay, and this should be IPv6 root BRF customer A 3000. The interface is serial 30 for this side. Next hop 10132. 10132. Enter. Use the example above to correctly configure fully specified static routes for customer B network. Okay, now configure for customer B the same for customer B, the same destination networks. Okay, the next hop is the same. The next hop is the same. Okay, but the local interface is different. Sub interfaces gigabit 105 and 108. Okay, for IPv4, IP root BRF customer B, the destination to 0, the local interface gigabit 10.5. 10.5 for this destination, and the same next hop. Enter. The next customer B 30 local interface gigabit 10.8, next hop 32. Okay, for this destination the sub interface gigabit 108. Okay, the same next hop 10.132. Okay, 10.132, very nice. For IPv6 root BRF customer B 2000 local interface gigabit 10.5, the same next hop 1012. And for the another destination IPv6 root BRF customer B, destination 3000 local interface gigabit 10.8, and the same next hop 10132. Okay, and before to do this, do the following: and do the previous pings. Customer A 3.1, customer A 2.1. Okay, try the ping to customer A 2.1. Previously failed. Customer A 2.1. Okay, customer A 2.1. Success. Customer A 3.1. Success. Customer A 20001. Success. Customer A 30001. Customer B 2.1. Success. Customer B 3.1. Customer B 20001. Customer B 30001. Success. And verify full reachability on R2, ping IPv4 and IPv6 on R3, loopback 0. Okay, from R2, ping loopback 0 on R3. Okay, but use source loopback 0 on R2 and ping loopback 0 on R3. Ping and go to R2, and ping 192.168.3.1, success. The IP, don't forget the source is loopback 0, success. Using IPv6 2001 DB8 ACAD 3000:1, success. And also on D1, IPv4 and IPv6 addresses on D2 belong 11, and the source belong 11. Okay, so go to D1, and from D1 ping interface belong 11. Okay, 3.1 30001. The source on D1 is belong 11. And look at this, on R2, you don't need to specify the VRF, the virtual routing and forwarding. You don't need to specify because only R1 is working with the VRF. So on R2 and D1 and R3 and D2, you don't need to specify the VRF. Okay, go to D1, ping and ping loopback interface on D2 192.168.3.1. My source interface belong 11, success. And also with IPv6 2001 DB8 ACAD 3000:1. Thank you very much. All is very good.